right, so let's find some derivatives, functions using the quotient rule. All right, so find the equation of the normal line drawn to the graph of f theta equals 3 theta divided by cosine theta when theta is 2 pi thirds. So first of all, we're going to find the derivative. This is the quotient rule because we have a quotient. And I'm trying to write quotient rule. And there we go, everything but a Q. All right, and it's a little reminder there, quotient rule. All right, so if we have the derivative of a quotient, it's going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator divided by denominator squared. Right? So u here is 3 theta and v is cosine theta. Right? Derivative of 3 theta is just 3. Right? We reduce the exponent by 1, right? So it would just be a 3. And then the derivative of cosine theta is negative sine theta. Right? So our derivative, f prime of theta, is going to be the denominator, cosine theta, times the derivative of the numerator, times 3, minus the numerator, 3 theta, times the derivative of the denominator, negative sine theta. That is a multiplication, not a subtraction. All divided by denominator squared, so cosine squared theta. All right, so let's continue simplifying. All right, so this is going to be 3 cosine theta, and that'll be plus 3 theta sine theta. You can factor out a 3 in the numerator, but there's really no point. Doesn't really make it that much nicer anyway. And then divided by cosine squared theta. Right? So that's enough simplifying. I mean, you could make it, no, you can't. It's really not worth it. I mean, dividing by cosine squared theta. We'll just leave it like that. All right, so now let's find our slope, first of all. Well, second of all, we found our derivative. All right, so f prime of 2 pi thirds, that's going to be 3 cosine 2 pi thirds plus 3 times 2 pi thirds sine 2 pi thirds. I'm going to write it this way, cosine 2 pi thirds all squared, because that's what that means. All right, so it's going to take us a little space to do the slope here. All right, so that's going to be just equal to. All right, a little reminder here. 2 pi thirds, so 2 thirds is more than a half. It's in the second quadrant there. All right, and so if this is 2 pi thirds, this right here, this angle, is going to be pi thirds. 180 divided by 3, 60. Right, so this is our 30, 60, 90. Square root of 3 is going to be the opposite side. Adjacent side is 1, and the hypotenuse is 2, regardless of how I drew that. All right, so cosine 2 pi thirds would be equal to, oh, excuse me, that's a negative 1, is negative 1/2. And anybody else? Sine. Sine 2 pi thirds is going to be a positive square root of 3 over 2. All right? So it's going to give us 3 times, and then negative 1/2, plus 3 times square root of 3 divided by 2. Oh, whoops, excuse me. Wrong thing. 3 is times 2 pi thirds, so that's just going to be plus 2 pi. And then sine 2 pi thirds is the square root of 3 divided by 2. All right, so the only other thing we can do is just a little bit of multiplying here. So this becomes negative 3/2, and then the 2's would cancel, plus pi square roots of 3. That's our slope. Well, you could use a decimal approximation, but we're just going to keep it exact. We just need now one last thing, and that is our point. All right, so f 2 pi thirds is equal to, oh, even better, we want the equation of the normal line. Yeah, we'll be extending the page a little bit. So equation of the normal line, we'll just have to take that and make it the reciprocal. Oh, there, it extended. All right, let's get our point. So f 2 pi thirds is going to be 3 times 2 pi thirds. It's going to be lovely numbers here. Times cosine 2 pi thirds. All right, so the 3's will cancel. It's going to be 2 pi divided by negative 1/2, which is the same as 2 pi times negative 2, so that's going to be negative 4 pi. So the point we have here is 2 pi thirds negative 4 pi. All right, so that's our point. If that's our slope, the normal line is going to be the reciprocal of that. All right, so it would be 1 over negative 3/2 plus pi thirds, or pi square root of 3. We shouldn't leave it as an improper fraction. We should multiply everybody by 2. And if we do that, this is now going to be 2 divided by negative 3 plus 2 pi square roots of 3. That's our slope. We're sticking to it. So the equation of the normal line is going to be, it's going to be a lovely equation here, y plus 4 pi is equal to 2 divided by negative 3 plus 2 pi square roots of 3, that's our slope, times x minus 2 pi thirds. And you know what? We're not going to, we could subtract the 4 pi from both sides, but we'll just leave it like this. Good enough. So not simplified, but it's correct, so good enough. Better than making it a decimal anyway. All right, so here's this one. Let's do another problem. Maybe that doesn't have such a unique equation to it. And I think actually it's going to be just finding some derivatives. Here we are just finding some derivatives. All right, so I'm not going to keep writing the product rule down. I think, because you can keep looking back at it. All right, but we need u, v, du, and dv. All right, so u is x squared minus 2x. The derivative would be 2x minus 2. V is x plus 2. Derivative is just 1. All right, so our derivative, f prime of x, is going to be the denominator, so x plus 2, times the derivative of the numerator, 2x minus 2, minus the numerator, x squared minus 2x, I got to be careful to use parentheses there, times the derivative of the denominator, times 1, all divided by the denominator squared. So let's simplify that. F prime of x is equal to, we'll have to FOIL here, because we had nothing we could factor out. X times 2x will be 2x cubed. And then we'll have negative 2x and positive 4x. So outer is negative 2x, inner is positive 4x. So that's going to be a positive 2x. And then 2 times negative 2 is a negative 4. Minus x squared plus 2x, all divided by x plus 2 squared. So f prime of x is equal to, combine our like terms, 2x cubed. Oh, we'll put these in order, descending order. So 2x cubed minus x squared plus 4x minus 4 divided by x plus 2 squared. There we go. There's our derivative. All right, let's find the derivative of the next one. All right, so u is tangent x. The derivative is secant squared x. Denominator, x plus 2. And the derivative is just 1. All right, so f prime of x is equal to the denominator, x plus 2, times the derivative of the numerator, secant squared theta, and then minus the numerator, which is tangent theta, or tangent x, times the derivative of the denominator, so times 1, all divided by the denominator squared. So we'll distribute and not be able to do much else after that, but so we multiply both terms, x plus 2 times secant squared theta. We got x secant squared theta plus 2 secant squared theta minus, excuse me, not theta. All right, that's not supposed to have a theta in it. We got x's. There we go. Let's get rid of it here too. Got carried away. Usually you see theta, not x. All right, so x times secant squared x plus 2 secant squared x minus the tangent x, all divided by x plus 2 squared. And there's nothing else we can simplify. Right? There's nothing we can pull out, nothing we can reduce, so that's it. Let's go on to the next one. Those are not like terms. All right, so we got h theta is sine theta divided by 1 minus cosine theta. So u is sine theta. The derivative is cosine theta. Denominator is 1 minus cosine theta. Right? And the derivative would be a positive sine theta, right? Because we'd have a negative times a negative. So dv is positive sine theta. Right? So our derivative, now it's theta, is the denominator, 1 minus cosine theta, times the derivative of the numerator. I think it's a theta. Derivative of the numerator was cosine theta, minus the numerator times the derivative of the denominator, right? So we have sine theta times sine theta, all divided by the denominator squared. All right, so let's simplify this. All right, so we have so 1 times cosine theta, that's a cosine theta. Negative cosine theta times cosine theta is going to be a negative cosine squared theta. And then we have minus sine squared theta, all divided by 1 minus cosine theta squared. You'd think that would factor, no, it'd be 1 minus cosine theta and a 1 minus cosine theta. Even if we were to factor out the negative, it wouldn't really help us because it's being added to cosine theta, I think. That'd be it. It's too bad. We can't do anything with that cosine squared theta and sine squared. Can we? You know what? I think we can. Let's continue on. So cosine theta, and then if we did minus, we pulled out the negative, cosine squared theta. Yes, we can. Yes, we can. Cosine squared theta plus sine squared theta. And if we factor out that negative, that's actually equal to 1, right? 1 minus cosine theta squared. So that's going to give us cosine theta minus 1 divided by 1 minus cosine theta squared. That looks better. And that is it because the signs are wrong in the denominator. Even if we, oh, wait. If we pull the negative out, never mind. I speak too quickly. All right, one last step here. Let me extend the page. Step by step, it's like, oh wait, we could simplify one more thing. Oh wait, one more thing. All right, there we go. All right, so we have h prime of theta is equal to cosine theta minus 1. Let's reverse the order here. I think it's easier to see this. All right, so we have negative cosine theta. Both signs are the opposite, so that's okay. Plus 1 all squared. So if we factor out the negative 1, so we have h prime of theta is equal to, factor out a negative 1 times cosine theta minus 1. Oops, sorry, I forgot to write the numerator above it. Cosine minus 1, and oops, somehow it lost its theta. There we go. Cosine theta minus 1, we could actually cancel out one of those cosine thetas. Right? So now we just have, and now I swear we are done. So now we just have a negative somewhere. Let's put the negative in the top. Negative 1 divided by cosine minus 1. And that's it. Whew. We were able to simplify that quite a bit. All right, now one with no trig functions. Next one over here. U is 3 minus, let's rewrite that as 3 minus x to the negative 1. Right, so du would be 0, for the derivative of 3 would be 0. So that would just be negative 1 times a negative 1, that would be a plus, so plus x to the negative 2. V is x plus 5, dv is 1. Right? So f prime of x is the denominator, x plus 5, times the derivative of the numerator, x to the negative 2, minus the numerator times the derivative of the denominator. So 3 minus x to the negative 1 times 1. It's a good idea to write the 1 in, just so that just tells you, yeah, you didn't forget anything. It just was 1. X plus 5 squared. So f prime of x is equal to, so we'll simplify. So this would be x times x to the negative 2 would be x to the negative 1. And x to the negative 2 times 5 would be times 5x to the negative 2. And by the way, we're not going to leave these negatives in here. And so then we would have minus 3 and plus x to the negative 1 divided by x plus 5 squared. Let's rewrite this, and then we're going to simplify. So what we're going to have is we're going to have an improper we're going to have a complex fraction. So we're going to simplify that complex fraction after we simplify these negative exponents. So this is going to be 1 over x plus 5 over x squared minus 3 plus, we could combine those, couldn't we? We got 2. Over x, right? This one and this one, we just combined them. All right. All divided by x plus 5 squared. Highest power of x in the denominator is x squared. So everybody gets multiplied by x squared. Everybody. So long as we do it to everybody, right? We haven't changed anything. It's just like multiplying by 1 over 1. All right, so now we have f prime of x equals, all right, so that's going to be a 2x plus 5 minus 3x squared divided by x squared times x plus 5 all squared. And it doesn't matter if you rewrite the terms to put them in descending order, that's fine. And there we go. We're done with this one. Another one done. Another one bites the dust. All right, we have lots of room for this one. All right, so u is x cubed plus 3x plus 2. The derivative, by the way, had that been an x squared plus 3x plus 2, that would have been an x plus 2 times x plus 1, and we could have reduced. But no, it's not. All right, so the derivative is 3x squared plus 3. And the denominator, x squared minus 1. The derivative is 2x. All right, so we have f prime of x is equal to the denominator, x squared minus 1 times the derivative of the numerator. All right, that thing is supposed to be a u. 3x squared plus 3 minus the numerator, x cubed plus 3x plus 2 times the derivative of the denominator times 2x, all over denominator squared. All right, so we have to multiply. All right, so x squared times 3x, that'll be 3x to the 4th. Outer terms, that's going to be plus 3x minus 3x. So that's going to be plus 2x squared. Excuse me, plus 3x squared minus, oops, sorry. That's not 2x squared. 3x squared, right, plus a negative 3x squared. That's no x squareds. All right, and then minus 3. The x squareds just dropped out. And then minus, that's going to be a 2x to the 4th. We've got to remember to distribute that 2x. So minus 2x to the 4th. And then minus 6x squared. And then minus 4x. All divided by x squared minus 1 squared. Let's combine some like terms. It's going to give us x to the 4th. Now I'll put them in descending order because, well, I can. Minus 6x squared minus 4x and then minus 3. And I don't necessarily assume that that's going to reduce, so, and I wouldn't really worry about it. I mean, if it were an easy reducing, I'd say, yeah, we need to reduce, but I think that'll be fine. If I figure out that it reduces later, then I will tell you and we'll reduce it. All right, let's try the next one. Given the function f of x equals 2x squared minus x minus 6 divided by x squared minus 4, find the derivative by applying the quotient rule. All right, so u is 2x squared minus x minus 6. The derivative is 4x minus 1. V is x squared minus 4, and the derivative is 2x. This would be a good idea, by the way, for you to think of what the derivative is for these in your head. All right, so our derivative, not necessarily the derivative of the whole thing, but just the derivative of the parts here, of the numerator and the denominator. It's going to be the denominator x squared minus 4 times the derivative of the numerator, 4x minus 1, and then minus the numerator, 2x squared minus x minus 6 times the derivative of the denominator times 2x. Oops, and I'm going into the next problem. All divided by x squared minus 4. All right, and you know, before we distribute, I kind of notice that the 2x squared minus x minus 6 is factorable. I wonder if we could reduce it all. So this would be x minus 2, x plus 2, and this is a 4x minus 1, minus, right, and then we have a 2x. And then 2x squared minus x minus 6. So multiplies to give us negative 12, adds to give you negative, not negative 4, I meant to write negative 1, negative 1, would be negative 4 and a 3. So 2x squared minus 4x plus 3x minus 6. Factor out the 2x. So we have x minus 2. Factor out a 3, x minus 2. So 2x plus 3, x minus 2. Now the reason is I want to rewrite this, because I was pretty sure I could reduce an x minus 2 everywhere. It's something. At least that's one thing I don't have to. And did we forget the square? Oops! X squared minus 4 squared. So that would be x minus 2 times x plus 2, and each one of those would be squared, because there would be 2 of them. All right, so we could factor out the x minus 2, and then that's it. And then we'd have an x plus 2, a 4x minus 1, and a negative 2x times 2x plus 3, and x minus 2, and squared, and an x plus 2 squared. And we could factor out one of the x minus 2. So actually, it wouldn't get rid of the x minus 2 completely, but it would get rid of, whoops, the squared part. So actually, it's getting rid of the square. So that's just going to be 1x minus 2. All right, this one's a little bit of work. All right, let's continue on. We have to give ourselves more space. F prime of x is equal to, now I'll have to distribute, but it's still a little bit less. 4x squared, and then minus x, and then plus 8x, so that's going to be a plus 7x. Minus 2, and then a minus 4x squared, that's going to cancel, and minus a 6x, all divided by, so now I've got an x minus 2 and an x plus 2 squared. So 4x squareds will cancel. So now I've got just an x minus 2. Oh, look at that. So f prime of x, as we expand the board a little bit. I didn't catch an x minus 2 that I missed. I guess when you add it all up, whoops, that's not what I want to do. I can't seem to find my cursor. Here we go. I just need to give myself a little bit more space. There we go. And I'll just keep going. All right, so f prime of x is equal to, we had an x minus 2 divided by x minus 2 times x plus 2 squared. So the x minus 2's will cancel, and so we'll come back and answer this last question, but we're taking up this amount of space. 1 divided by x plus 2 squared. Boy, that really simplified quite a bit. Let's see what happens if we simplify and then apply the quotient rule. All right. So we have u is equal to, actually, excuse me, before we do that, simplify. So f of x is equal to, we already know what 2x squared minus x minus 6 factors to, right? That was an 2x plus 3 and an x minus 2. And then this would be x minus 2, x plus 2. Cancel those out. So now we have f of x equals 2x plus 3 divided by x plus 2. All right, so u is 2x plus 3. The derivative is 2. V is x plus 2. The derivative is 1. So we don't need much space because we don't got much space. All right, so f prime of x is equal to the derivative of the denominator, x plus 2, times the derivative of the numerator, times 2. And then I'm going to have to squeeze it over here, minus the numerator, 2x plus 3, times the derivative of the denominator, which was 1. all divided by x plus 2 squared. Right, so f prime of x is equal to 2x plus 4 minus 2x, excuse me, almost got my parentheses, minus 2x minus 3, all divided by x plus 2 squared. Right, well, I'm going to be able to combine like terms. F prime of x is equal to 1 divided by x plus 2 squared, and we're done. And notice we got the same answer. I feel really good about that because I had to do a lot of work on that first one. Whew. Make sure you do all that work. Feel free to pause and you'll get all that in. So what's the lesson to be learned? Because it's an important lesson. And if you don't see it right here, you don't see the work, you won't realize the lesson. So what's the important lesson from the algebraic analysis above? Putting it in capital letters. Always simplify first. If you can simplify, do it. All right? Saves us a lot more. It was a lot more effort, and I made it a little bit easier because I did factor out and reduce. It would have been even worse if I didn't do that on the green side there. But look how much easier the red side was. All right? So you want these to be as simple as possible. If you can simplify, do it. And we're going to move on. I think I'm going to end this podcast. In the last podcast, we're going to do some graphs and tables and all that good stuff. All right, bye for now.